mathletes. Today we're going to investigate the surface area of rectangular prisms. So here's my situation. I have 24 blocks and I would like to put them into a rectangular prism. I want to figure out how many different rectangular prisms I can make, and I also want to see if they'll all use the same amount of material. If you would like to review how to find the volume of prisms, please use my QR code to the left. In order to keep this very organized, I decided to make a table. In my table, I need to know the length, the width, and the height of my boxes, and they're all in centimeters. I know the volume needs to be 24 cubic centimeters because I have 24 blocks, and each block is 1 cubic centimeter. After I come up with the ideas of the different boxes, then I'll calculate the surface area and see if they all do use the same amount of material. So I did the first one for you, and I came up with 4 by 3 by 2, because the product of 4 and 3 is 12, and 12 multiplied by 2 is 24. Now, if I said that the box was 3 by 4 by 2, it would still be the same box. I would just be looking at it from a different perspective. So again, changing the order of the numbers does not change the type of box. It just means that you have moved the box maybe onto a different face. So this is one of the boxes. There are 5 remaining boxes left using just whole numbers. And so you can pause the video here and see if you can come up with the next 5 boxes. All right, welcome back. Let's see if this is what you got. It might be in a different order, and that's fine too. I have 12 by 2 by 1, 8 by 3 by 1, 6 by 4 by 1, 6 by 2 by 2, and 24 by 1 by 1. Notice that their products all equal 24 cubic centimeters. And again, you could reverse these orders, it's still the same box. So now that we have the first 4 columns filled in our table, we now need to calculate the surface area to see if they all use the same amount of material. So let's start with the first one. Actually, let's draw it out first. That might make it easier. So here's my first box, my second box, third, fourth, fifth, and 6th, okay? So you can see my dimensions. Like I said, if you put them in a different order, it's fine. It just means that it's lying on a different face. So we'll start with the surface area of 4 by 3 by 2 first. And for this, I'm going to use a net. Okay, so let's draw a net. Here we go. Now, I want you to think about, what do you notice about each of the 6 faces? And you can pause for a moment here and then see if you can come up with something that you notice. All right, so let's see. Did you notice that the top and bottom are the same? I kind of gave you a hint when I used colors, but you can see that they're in the purple. And you can also notice that the front and the back are the same. And so are the left and right sides. So those areas are also the same. So if we know that the length is 4 centimeters and the width is 3 centimeters and the height is 2 centimeters, we can calculate the surface area. So if we look at the top and the bottom, which is the purple, the length multiplied by the width is 4 multiplied by 3. And I'm going to multiply it by 2 because I have a top and a bottom. So 4 multiplied by 3 is 12, and 12 multiplied by 2 is 24 squared centimeters. Now let's look at the front and the back. For the front and the back, it's the length multiplied by the height. So 4 multiplied by 2, which is 8. And since there's 2 of them, 8 multiplied by 2 is 16. So 16 squared centimeters. And lastly, the sides. We have the left and the right sides, which is the width multiplied by the height. So the width is 3 and the height is 2. So 3 multiplied by 2 is 6, and 6 multiplied by 2 is 12. So 12 squared centimeters. And now I just need to find the sum of my 3, and I get 52 squared centimeters. So I'll put that in my table. The 4 by 3 by 2 uses 52 square centimeters to cover. Now let's look at the next one. the 12 by 2 by 1. I'm not going to draw the nets for the rest of them, but I will write it out as length, width, and height. So the top and bottom is length multiplied by width, so 12 by 2, and then I multiply by 2 again because there's a top and a bottom, so 48 squared centimeters. The front and the back is the length multiplied by the height, 12 by 1, and again multiplying it by 2 because there's a front and a back. And lastly, the left and right is the width multiplied by the height, 2 by 1, and we're going to multiply that by 2 because there's both a left and a right side. And the sum of those three areas, is 76 squared centimeters. So we'll put that in our table. I'm going to continue on with the rest. If you'd like to do it on your own, that's fine as well. But if we look at the 8 by 3 by 1, again, we've got the top and bottom being 48 squared centimeters, the front and the back 16 squared centimeters, and the left and right 6 squared centimeters for a total of 70 squared centimeters. We have the 6 by 4 by 1, which is 48 squared centimeters, 12 squared centimeters, 8 squared centimeters, a total of 68 squared centimeters. The 6 by 2 by 2, again, top and bottom is 24 squared centimeters. The front and back is 24 squared centimeters as well. And the left and right is 8 squared centimeters, so a total of 56 squared centimeters. And the last one, oh, that's a long one. We've got the 24 by 1 by 2, which is 48 squared centimeters, and 48 squared centimeters again, and 2 squared centimeters, a total of 98 squared centimeters. So if we look at our drawings again, and underneath I put the surface area, what do you notice about the rectangular prism that has the greatest surface area? And what do you notice about the rectangular prism that has the least surface area? So this one here looks like the greatest surface area at 98 squared centimeters, and this down here is 52 squared centimeters. Can you come up with a conjecture or a rule? I'll let you think about it. If you want to pause, you can pause it and then come back and I'll let you know what I came up with. Okay, so I noticed here that my numbers are really far apart. The distance between 24 and 1 is big. Where these numbers are close together, the 4, the 3, and the 2, compared to the 6, the 2, and the 2, or even the 6, the 4, and the 1. Another way you might want to think about it is the sum of the dimensions. The 24 plus 1 plus 1 is going to give you 26, where this is the 4 plus 3, which is 7, plus 2 more is 9. So 9 is definitely less than 26. Even this one is 11, or this one 10. So if you think about the type of prism that would use the least surface area, are the numbers that are the closest together. So that would be a cube. So if you had one that was like 2 by 2 by 2, 3 by 3 by 3, 4 by 4 by 4, etc. Now with 24, it's not a perfect cube, so we could never have it with whole numbers like that. So this is the one that has the least surface area. I hope you had fun investigating surface area of prisms. And again, I hope this makes sense.